Hello, welcome to Pre-Calculus. I am glad to be here, being able to talk to you today. Hope you're doing well. And we are about to learn about something called the law of cosines. Now, first, let's review the law of sines real quick. The law of sines applies if you have angle, side given to you, okay? Or side angle given to you. However, this is what we call the ambiguous, spell it right here, ambiguous, there we go, case, okay? So you have two possible triangles in this case, all right? All right, so today we're going to learn about the law of cosines. The law of cosines is for when you're given side, angle, side. Notice the angle is between the two sides. In side angle, the angle is not between the two sides. Also, you can do the law of cosines to find angles, okay? If we had side, we can use it as well to find all the angles, okay? If it was side angle side, we would be able to use it to find the third side and also to find the two other angles. All right, so let's start up the notes here. You have this same PowerPoint that I attached in case you want to reference it later. It'll be easier that way, but I figured I'd explain it to you guys as we went through it real quick here. All right, so here is the law of cosines notes. All right, so this is the law of cosines. It kind of looks somewhat similar to the Pythagorean theorem. So this is the law of cosines if we are given an angle, and the angle is in between the two sides. So there's actually three variations, but they're all three the same basic setup. Here's angle A, and it's between sides B and C, okay? So this equation allows you to solve for side A, okay? And then once you solve for side A, you can use the law of sines if you want to figure out the other missing angles. Might be easier. Or you can use one of the other cosine variations. On the next slide, you'll see that to find the other angles, okay? So these formulas here are useful if you're looking for the sides, all right? Now, these formulas are basically the same formula, okay, only we reworked it and we solved for the angles, okay? So you see A, B, and C are the angles, and you can use these formulas to figure out the angles once you know all the sides, okay? So yeah, you could just go ahead and use these formulas pretty directly. Now remember, when you're using these formulas, okay, you're plugging the numbers in, all right? But that's not just the answer. You have to take the inverse function to get rid of the cosine function, all right? So you have to take the inverse cosine to whatever this side is here, okay? And then you use your calculator and make sure you're in degree mode, most likely. All right, so solve the following with side angle side. All right, so we're using the law of cosines, and they're giving you side angle side. All right, now let's go ahead and look at this here. All right, we have to figure out the sides first. We can't figure out the other angles first. So we're going to use this b squared variation because we're given angle B, so we're going to use the b squared variation to find side B. All right, so just plug in A and C, okay? And if you mix up A and C, it's not a big deal, but you know, remember the side is opposite its corresponding letter. So just plug all that into your calculator, and for accuracy's sake, if you don't want to type all of this in at once, which personally I would do, if you want to just type in cosine of 35 first, you should use 4 digits. Okay? All right, so there's simplifying it more here. B squared is equal to this number, so remember you got to take the square root and round it to the nearest tenth, 29.5. All right, now let's see how we get angle A and C. Okay. All right, so we could either use the law of sines or the law of cosines on the previous slide to find the other angles. All right, so I think the law of sines is a little quicker and easier. I'm just going to use the law of sines here. So now that we have the side that corresponds with the given angle, that's one side of the law of sines. All right, we're going to do cross multiplying. 19 times sine of 35 is the top, and then 29.5 times sine of C is the other side. So we then divided by 29.5, and that's how we got this thing here. So plug it into your calculator, 4 decimals for accuracy's sake. And remember, at this point, you want to find the angle. So always to find an angle, you use inverse trig functions. So sine inverse sine to the -1 of 0.3694 to get the angle. And then you would be foolish if you decide to do all this work again. Instead, you could just subtract from 180 degrees to figure out angle A. Voila. Okay? If you're using the law of sines for side-side angle, be careful of the ambiguous case. So, if you are in doubt, to avoid confusion, save the largest angle, which is across from the largest side, for last. Okay, that's why I didn't do angle A here, because this angle A could have been obtuse, and since we had side-side angle, it's kind of ambiguous. So remember, sine inverse functions do not give you obtuse angles. They only give you angles between 0 and 90 degrees. Okay, so save the largest side, the angle associated with it, for last. Okay, that's why we chose to do C. Okay, because C was across from the smaller side here, and so it's going to be a smaller angle. All right, that's it. Let's look at example 2. So this time we have side, side, side case. You know all the sides. We're looking for the angles. All right, so you cannot do this with law of sines. You have to use law of cosine. So just plug in all the sides into the formula. All right, looky. What you got there? Not so bad. All right, simplify it more down. Now, cosine inverse. Now, the cool thing about cosine inverse is that it will actually give you the obtuse angles where appropriate. So you don't have to worry about this ambiguous case. All right, sine inverse doesn't, because it doesn't have those obtuse angles built into the inverse function. Okay, so we do the cosine inverse and we get 33.6 degrees. Then you have to repeat. You could do the law of cosines again, or you could do the law of sines now. And remember, you don't want to use the largest side because that angle could be obtuse if you're using the law of sines. So you want to save that one for last. Okay, got it? All right, now let's do cross multiplying once again, and then dividing by 5. And then you're going to do sine inverse here to figure out the angle. So you got 50.8 degrees. And let's see, we subtract from 180 what we know. We get B is 95.6 degrees. So we do get an obtuse angle. Ah, boy. So it paid to do the smaller side first. All right. Otherwise, you would have been like wrong. Okay. So please follow my advice there. All right. Then there is something called triangle area and Heron's formula, which is just a little bit of a tidbit thrown in here. Okay, so you could figure out the area of a triangle by this function here. Okay, so 1/2. So if you know 2 sides of the triangle, and you know another angle that isn't opposite those 2 sides, okay, you can actually figure out the area of a triangle. Okay, there's an example coming up soon. Okay, so Heron's theorem. A, B, and C be the sides of a triangle ABC. Let S denote the semi-perimeter. Okay, so semi-perimeter is actually half of the perimeter. Perimeter is all the sides added up. Okay, so add them all up, divided by 2. This is another formula you can use to find the area. Okay, so you can actually find the area of a triangle by just knowing the sides of the triangle. Okay, you don't have to worry about knowing the height of the triangle, which is kind of cool, because usually we always got to figure out the height of the triangle. So neat formula here. You need to find the semi-perimeter to use it. All right. So here is find the area of the triangle. A equals 52 degrees. B is equal to 14. C is equal to 21. And so you can use this area formula that we had. So I didn't really draw out the triangle for you, but I'll try to draw it out real quick here so you can see what it looks like. Just bear with me. I'm going to pause the video and draw. Boom! There it is. Triangle back. So basically this formula looks like it can be used when you have a side, an angle, then a side. You can figure out the area by substituting the angle and the sides. Yep. Now, I mean, I just kind of drew it whichever way I thought, but remember the angle, okay, has a side with the same name across from it. So A goes with A, and so we didn't know A, so that's why I put a letter there, okay? So let's make sure you're in degree mode, and there you go. You're finding the area, it's units squared. Here's an example of Heron's formula. Okay, you're given the side lengths. So the first thing you got to do is find the semi-perimeter, okay? Well, first, before we even do that, the question's asking you, is this even a triangle? Okay, so how do we know if something is a triangle or not? Well, to be a triangle, the two smaller sides always have to add up to be more than the third side. So just add 19 3/10 plus 22.5, and you know that's well above C. Okay, so that definitely is a triangle. All right, now to use Heron's formula, plug in what you know. And also we got to figure out S. So you add up all the sides and divide it by 2, because the semi-perimeter is half of the perimeter. Okay, so there you go. Add them all up, divide by 2. There you go. And substitute it in, and guess what? You have to just basically put everything underneath the calculator. You could wait to do the square root in the end if you want to. Yep. And there you have it. You've just figured out the area with not knowing anything, which is kind of cool. Well, not knowing the height, you just knew the sides. All right. Okay, some important notes. The law of cosines, you can always use it to find both obtuse and acute angles. Law of sines can only be found can only find acute angles. You have that ambiguous case, okay? So if you're using law of sines, you better make sure that the side that you're using doesn't get associated with an obtuse angle. That's why I always said if you're using the law of sines, make sure you don't pick the largest side, okay? Because you will then guarantee yourself to avoid the obtuse angle, all right? Cosine inverse has the obtuse angle range. Sine inverse does not. Law of sines, though, is quicker. Okay, so just follow my advice. You're good. All right, I'm posting a Math Excel. I want you guys to try to do your best on that, and that won't be due till the end of the day on Friday. If you have to do the test corrections, please do that today for homework. All right, thanks. Have a great day, guys, and God bless now.